Okay, so now that we verified all of our labels, relabeled things, now we got to process the specimens further. Different ways to do it. It just depends on what kind of test you have. So 99% of these purple tops do not get spun down. This is a whole blood test. It's a CBC. There are those rare tests where you would spin this down. Most of the time you don't. So this is ready to get sent back to the tech running the CBC instrument. This green top tube though, this has a gel in it which separates the plasma from the red blood cells. In order to do that, we need to centrifuge this down. So what we're going to do is place it in here and make sure it's balanced out. We're going to close the centrifuge, and this is already preset to 5 minutes. So we're going to press play, and it's going to spin and split off the plasma from the red cells. So again, depending on what test it is, some tests only sample the plasma or serum, hence why we got to spin it down. Other tests sample the whole blood, which is why we don't spin this guy down. So the centrifuge is done spinning. It'll make a sound kind of like that one just did. We're going to take it out. And then I like to verify that everything is good. What I mean by that is sometimes we'll get hemolyte samples that are no good. We'll immediately put those in for a recollect because it's going to produce erroneous results anyways. So this sample looks great. There's a gel separating the reds from the plasma, and the plasma is what's going to be sampled by the instrument. So now we'll take the specimen and hand it over to the person in chemistry. So we'll put that here. The person running in chemistry is then going to grab it and take it over to the instrument. So all we do here is take the cap off, put it on one of these racks, barcode facing out so that the instrument can read it. Rack is going to be facing towards this side of the analyzer. All analyzers are slightly different. This is just how this one takes it. We're going to hit start and start. I'm going to do a cycle through. This is where the instrument mixes different reagents with the patient's plasma or serum. It is pipetting the patient samples with reagents, and it's doing a chemical reaction that then gets detected by a light source. So it's that spectrophotometric reaction that it's doing for all of the tests that you see on the screen. So here's our test patient that we ran earlier. As you can see, it is done. We can go into details, and here we can see all the results from that CMET order. All these instruments are interfaced, so we really don't need to do anything unless there's a critical. There are certain flags in place that will hold critical results for us. Those will not cross into the LIS automatically. Those we have to call the nurses on. So before they cross, it'll flag us on our computer and our middleware system. We'll call the critical results to the nurses, we'll document who we called it to, and then we can release those results into the hospital chart. But there's nothing here, there's no flags in any of these results. Everything looks perfectly fine. So we know that this crossed over automatically without us having to do anything else. Okay, so this is our middleware system, Remisol. All of our main chemistry analyzers are hooked up to Remisol. This just kind of tells us how far along a patient's test is by using a little pie chart. So red means that it hasn't even been seen. Green means that some tests are done. And then the remaining red part means that those are still some tests that we're waiting on. For critical results, it'll highlight it orange and it'll put a critical flag. We're going to double click to go into this patient's results. And then if we scroll over here, we can see that it actually highlighted the value that is critical also in orange. So more specifically in this example, the CO2 is critical at 45. And there are hundreds of rules written into this middleware system that takes all of the raw data from the instruments and kind of puts it on a scale, and it cuts off a lower end of the scale and the upper end of the scale. If it goes above those parameters or below those parameters, it considers it a critical or an abnormal value. So each test has its own set of rules written for it. And so that's why this interface exists, is to help the instrument's data translate into something that we can understand and read and what needs to be called and whatnot. So I just want to double check that everything crossed over. I'm going to go into lab inquiry. I guess there's multiple ways to check. You can check directly in Epic in the patient's chart. But if it goes into our lab inquiry here, that means that it's crossed over into Epic as well. All of our notes, if we had any criticals to call, all that will show up in lab inquiry as well as in the patient's Epic chart. So I'm going to go and search this by container ID, which allows me to scan the barcode to search up the results or that test. So here's my patient. Here's my order that I'm looking up, which is that CMET. I'm going to hit on Get Results. And here's all the results exactly as we saw on the instrument. So again, since it's interfaced, it all crossed over automatically. You'll see here some asterisks that we didn't see on the instrument. So our instrument has wider ranges, and when it crosses into the laboratory information system, we tighten up our ranges on what's considered normal or abnormal. You can see these ranges here off to the side. For example, the AST was 43, but the normal range only goes up to 41. So since it's slightly elevated, it put a little asterisk on there letting you know that this result is slightly elevated. If it was a critical result, you would see a double asterisk along with our comment that we documented who we called that critical result to. Okay, so now that we're completely done with this tube, we're going to go ahead and rack it in with our general population here. In order to do that, we're going to go back to our smart specimen management, routing, and tracking. We're going to go to processing, rack assignment. We're going to enter in our rack ID, which is 6963. And here it wants us to load in slot 28, which is our next open slot here. So all I'm going to do now is scan it into this rack, place it in the slot.